In this video, we're going to continue talking about the different levels or scales of measurement. In the previous video, we have talked about that nominal and ordinal variables may be collectively called non-metric variables. In this video, we're going to specifically talk about the metric variables, which are the interval and ratio data. So, interval data. Interval data can be ordered, and differences can be taken. At this level, it makes sense to compare the differences between data values. And 0 is a placeholder, or there is no true 0 point. So for example, score in an exam. So now, we can name the data, we can order the data, and this time we can actually now compare the data. In interval data, the differences between the data values is already important. For example, in our given here score in an exam, the score of 10 over 10, 9 out of 10, and 8 out of 10 will now be different. It will, unlike in ordinal data wherein the rank, the first and the second, we cannot actually determine, or it's quite impractical to determine a difference. Here, it's important now that we can see that they have actually 1 point difference. 1 point difference. And that 1 point difference might have a specific interpretation. However, please take note one important thing. Please remember, in interval data, 0 is a placeholder, or there is no true 0 point. Let's take the score in an exam as an example. If you get 0 out of 10, that does not mean that you do not actually know anything at all. This means that you got 0 in the specific exam for a certain number of factors. But getting a 0 in an exam doesn't mean that you do not know anything. Hence, we can consider exam as an interval data. The next level of measurement, which is actually just quite related to interval data, is called the ratio data. Data can be ordered, differences can be taken, and now the ratio between data values can also be found. For instance, it makes sense now to say that one data value is twice as large as the other. 0 means nothingness or absence of either the characteristic or the respondent. For example, age and height. So, interval data and ratio data are quite interrelated. It's just the fact that in ratio data, it makes sense to say that one data value is twice as large as the other. In interval data, for example, if I get, let's say, 2 out of 10, and then another score is 4 out of 10, it doesn't usually make sense to say that 4 is twice as large as 2, because that's a score. However, in ratio data, for example, in height, for certain studies, it makes sense to say that a height of 2 meters is half of 4 meters, and 4 meters is a double of 2 meters. So it depends on the context again. Again, we're talking about context. It depends on the context of the actual study. Now, there's one thing to note here. The variable age. Theoretically, age is ratio, because by definition of age, you have to experience living in the outside world. There are some who are saying that sir, you begin aging when you are already inside the mother's womb. That is something that is actually cultural in nature. However, science tells us that the scientific definition of age is your experience of life outside the mother's womb. So, again, context comes into play. If we're talking about age, as in the theoretical definition, then we're talking about age as ratio data. However, if we're talking about of age that is something cultural, then age is considered as interval data. So you have to be extra careful because in some cultures, once once you are conceptualized, I guess, and once you are inside in your mother's womb, you are already considered 1 year old. So this is something cultural and we cannot ignore that. That makes age interval data. So interval data and ratio data are quite flexible to each other, and in most cases, the basic statistical tests will allow both interval and ratio data. Here's a summary of the different levels of measurement. We have the first one, which is nominal, categories only. So for example, student states. We have ordinal, categories are ordered but differences are meaningless, such as sizes. Interval, differences between values are meaningful but there's no natural starting point. Just like temperatures in degrees Fahrenheit. 0 degrees Fahrenheit doesn't mean there's no heat. While ratio, like interval level, but there is an absolute zero. Or zero would mean nothingness. Just like distances. So here's another way to look at our levels of measurement based on the classification of data. Usually, qualitative data are nominal and ordinal levels, while quantitative data are interval ratio levels. So one tip on determining the level of measurement, start with the highest level that can be justified for the entire collection of data. If not justified, move to the next level till you reach nominal. Let's have an example of how we determine the specific level of measurement of a certain variable. Say, for example, let's have gender. Although you might have an idea already of what the level of measurement of this variable, let's still see using the tip. Take note that there will be something about sex and gender in our forums. So, first, as the tip says, see if gender will fit the highest level of measurement, which is actually ratio. As we all know, in gender, it's not quite appropriate to say that twice a male is a female or half female is a male, something like that. So that would mean ratio is not appropriate. How about interval? Is it appropriate to say that gender is an interval in nature? Actually, it's quite difficult to find the differences between a male, a female, then a bisexual, then a transgender, and those things. So, interval will not be appropriate. How about ordinal? Do we know which one will come first? Actually, we cannot do that. So, ordinal cannot be. Hence, the only one left is nominal. So therefore, we can say that gender is nominal in level. So that's how we basically determine whether a variable is of what specific level of measurement.